Hi everyone, next function we're going to tackle with is the quadratic function. So, this function is the general form of ax squared plus bx plus c. And I hope you also recognize the function from high school, but let's just remind ourselves a little bit how it comes about, and let's just use the case of this in the simplest form, y equals x squared, and let's make a table for it. Okay, we just need to have a couple of values to get the gist of how this function works. Okay, so look, this function tells us to take whatever is in place of x to the power of 2. So 0 to the power of 2 is 0, 1 is 1, 2 is 4, 3 is 9. And now look, if we go in the opposite direction, negative 1 to the power of 2 is 1, and we got 4 and 9. So we clearly see that there is some symmetry within this function, and it makes perfect sense, because any negative number taken to the power of 2 gives us a positive number. So now, how can we draw this function? So we start at 0, and we see that if x is either 1 or negative 1, value of the function is 1. Okay, maybe a little bit closer. Again, you know the robot, it's really hard to draw those things. Okay, then if x is 2, value of the function is 4, and the same goes for negative 2. Now, we could also imagine that if value would be 3 or negative 3 of x, if argument would be 3 or negative 3, the value would be 9 on both sides. So, if I would connect all those possible points, I should get a line, a curve that looks like this. Okay, and right away we can see a couple of features of this function. We clearly see the symmetry, right? So the bottom tip of the parabola, which we will call vertex, actually will make a point through which, if we draw a perfectly perfectly vertical line, it will serve as a mirror, and both of the ends of the parabola will be mirror reflections. But the second thing we should notice, and what we should definitely contrast with linear function, is how this function progresses. Because look, here, when we went from 0 to 1, value of the function changed by 1. But then it changed by 3, then it changed by 5. 4 squared is 16, so increase would be by 4. So look, we see that this function here is growing, and it's growing faster and faster and faster and faster. So each 1 unit increase in x leads to higher and higher increase in y. And of course the same works when we put negative numbers, right? But this time, of course, remember, here is the direction of growth of numbers on x-axis. So here we see this actually as the function is declining, but it's declining slower and slower and slower. Okay, now let's make one simple addition to what we had over here. Let's just say now that we've got function negative x squared. So look, if I'm going to put minus in front of x squared, basically all I need to do is to take the values I've obtained for x squared and put the minus in front. Right? So I got negative 9 0, -1, -4, -9. Okay, so if I'm going to draw this function right now, it will look like this. And look, I know you might probably not see it on this graph, but now what we have is a mirror reflection of the old curve with respect to x-axis. And look, this is the general rule. Every time when you impose a minus in front of the entire function, you will see mirror reflection of the function with respect to x-axis. But this one we will practice a little bit more later when we will tackle with reciprocal function. What is important to remember here is that it gives us a very clear indication of what A brings about for a quadratic function. Every time if A is above 0, so if A is positive, we will have parabola with hands up. Every time when we will have a minus in front, we will have parabola with hands down. Look, you can remember in a different way. Positive number, smiley face, positive emotions, right? Negative number, negative emotions, frowning face. You can think of it as a valley or of this as a hill. But to be perfectly honest, I usually like the students to remember this type of shape as a cave. Why? Because this is an example of concave function. And concave functions are the functions that look like caves. Not of course a formal definition based on derivatives. We will derive a little bit later. Now, this is an example of a convex function, which we can think of as a function that does not look like a cave. Okay, so that was the first thing we needed to do. We needed to establish when the parabola is hence pointed upwards and hence pointed downwards. And we did this. But this is still not enough for us to be able to draw this function. The second thing we would like to know is when the parabola, is cutting through x-axis, when it intersects with x-axis. How we can know that? Well, actually, all we've got to do is to solve equation like this, right? Look, we know that at this point and at this point, value of value of the function is 0. So we just need to solve this equation. Okay, but as you will see, solving this equation is a little bit problematic. So the better way to do it is to solve it just once and remember what is the up. Okay, so let me change this a little bit to make it easier. And so, what is the first thing I'm going to do? First, I'm going to take this C and I'm going to move it to the other hand side of the equation. Okay. Then, in the second step, what I want to do is to get rid of A next to x squared, right? So now, I'm simply dividing both sides of this equation by A. For these purposes, we of course assume that A is different than 0. And it makes perfect sense because if A is 0, we would end up with just linear function, right? So, what I'm doing here is divide both sides by B. So, we've got x squared plus B over A, x minus C, equals to negative C over A. And now, we need to take a step that is, how to say, not very easy to come Because what I need to do is to add the same number to both hand sides of this expression, but I'm going to add it artificially, just to obtain the expression that I want. But remember, as long as I'm adding the same number to both sides of this equation, this is clearly permitted practice. And look, the expression I'm going to add is plus b squared over 4a squared. Okay, so now I just need to add. So I've got I got x squared plus b over a x plus b squared over 4a squared, and it's equal to b squared 4a squared minus c over a. Okay, so what to do with this now? Okay, first, actually, let's deal with this side of the equation. Look, if I want to add those two, I need to put them in common denominator. In order to do so, I just need to take this, multiply numerator by 4a, and multiply denominator by 4a. So look, as a result, I'm getting b squared minus 4ac divided by 4a squared. Okay, so now that we have this side of the equation, let's just say in the form that we want, what should we do next? And maybe with the next step, for the next step, we need to remember one formula we haven't discussed, but I assume you've done it in high school many times. How much is y plus z squared? Well, we of course remember that this is y squared plus 2yz plus z squared. Now, why this formula? Because when you look at what you have over here, we definitely can make some connections. What connections? Look, x squared can be thought of as y squared, right? So, making a comparison, in our case, x is somehow relating, I don't know how to write relating to y, right? Okay, let's just say that they are equal, right? From this formula. Now, look, if I'm going to take square root out of this expression, what will I get? Well, square root out of b squared over 4a squared is equal to b over 2a. And look, now I hope you start to see what we actually got over here is that this is our z. Now, finally, so we see that here we've got z squared, here we've got x squared. Now we want to have 2yz. And look, if I'm going to take 2, multiply it by y, which is x, and then by z, I'm going to obtain b over a x. So clearly, we can compact this expression to the form x plus b over 2a squared. Okay, so what should we do next? Well, now this expression is in squared. So if we want to solve it for x, probably we need to take both hand sides of this equation to the power of 1 over 2. Well, or simply, we just need to take square root out of both sides of this equation. Look, if I'm going to do this in case of this expression, it's really easy. All we obtain is x plus b over 2a, right? Now, what will we have on the other hand side? Well, on the other hand side, we should have square root of this and square root of this, and square root of this is 2a. But, look, the problem with this solution is, of course, that we assumed at this moment that this expression over here is going to be positive. Does it need to be positive? Well, not necessarily. Because if we multiply two positive numbers, we are getting positive number. If we multiply two negative numbers, we also get positive number. So one more thing we need to add over here is that this can either be positive or negative. And look, at this moment, we are ready to obtain the solution. And the solution here is, in order to get it, all we gotta do now is to subtract b over 2a from both sides of the equation, and we get that x is equal plus minus, is equal to negative b plus minus square root of b minus 4ac over 2a. Okay, look, this formula is maybe not the most complicated, but it's also not the least complicated formula. So let's introduce a shorthand. From this moment on, delta will mean for us b squared minus 4ac. And look, this actually leads us to it allows us to reduce this equation to the form that you probably know from high school. Okay, and look, if we know that this formula will allow us to find zero places or roots of the quadratic function, then we can use it, of course, to find those places, but with certain restrictions. Look, we should know that if delta turns out to be a negative number, we cannot take the square root. Of course, at this moment you probably know, but what if we use imaginary numbers? Look, imaginary numbers we're going to leave for later. For now, we're just going to stick to the main rules you have been using in high school. Okay, so if I want to find roots for zero places of the parabola, what should I do? Well, we will start always in the same fashion, right? We're going to start by delta. Delta is equal to b squared minus 4ac. And look, this means that we can get three possible cases in terms of delta. First, what if delta is a positive number? Well, if delta is a positive number, we can easily apply this formula, and look, what will we get? We will get two solutions. So, let me rewrite this a little bit. So we will have x1 and x2. x2, and they are equal to negative b plus minus square root of delta over 2a. And look, there is again some symmetry implied even in this formula. Because look, here, if delta is positive, we will have two different numbers. Okay, let me show you this with an example. Now, if I have so let's just say that I calculated negative b over 2a. I got it. Now, look, from this number, first I need to add a positive number. So we will have some x1, let's just say, over here. And then I need to subtract positive number. So I will have x2 somewhere over here. And of course, let's assume for simplicity that that a is bigger than 0, then our parabola will look like this. Okay, so this is the case number 1. What if now it turns out that we calculated delta, and delta is equal exactly to 0. Okay. Again, let's turn into this formula that we've obtained just now. If delta is 0, we can take square root of 0, but it is 0. So what we will get is just one root, one 0 place. We call this repeated root, right? Because you can see that it's like we have one the same root twice. So, if this is 0, it turns out that the place where parabola intersects with the x-axis is simply given by negative b over 2a. And look, in this case, it's actually not intersecting, but it is tangent. It is tangent. So, but it still takes the value of 0. But look, this value is very special. Why? We will explain this in a second. For now, just remember that when we have delta equal to 0, we have just one repeated root, and we obtain it with the same formula, just we can simplify it because we don't need square root of delta. Okay, and finally, the last case, with delta lower than 0, we know that we cannot take square root out of negative number. So, in this case, parabola will not have 0 places. So it will either look like this with positive a, or like this with negative a. Okay, so look, that was the second step we needed to take in order to draw parabola properly. Now, there is one more interesting point we should be able to calculate. And this point is the vertex I mentioned with you before. So this is the lowest point or the highest at the parabola. And this is the point through which, if I'm gonna put a vertical line, this point will divide the parabola into two mirror reflections, right? Now, how can we obtain this point? As it turns out, we already did. Look, as it turns out, if I want to find the formula for vertex, I can just use this formula. Because in this case, we see that this is vertex, and we already obtained this formula. We just need to disregard the delta. And look, it makes perfect sense. This point, because it will work for every case, of course, not only this case. this must be our vertex. And vertex, with this formula, can be calculated for any case, but of course, in this case, with 0, 0 delta, it is unnecessary. Okay, but we would also like to know what is y of vertex. So, look, we've got this x vertex, but we want to know this y vertex, right? We've obtained x coordinate so far. Now I want to know what is y coordinate. How can I obtain it? Okay, in order to do so, all we've got to do is come back to this formula for the quadratic function, and we need to just notice a couple of things. Look, y vertex is simply the value for x vertex. So if I just take this value, substitute it in there, I should get it at some point. So, in other words, y of vertex is simply a, and now look, instead of x, I'm plugging this negative b over 2a. Now, here we have square plus b times negative b over 2a plus c. Okay, let's calculate it all out. And we've got that this is a times b squared over 4a squared, right? Now, out of this, I'm getting that this is negative b squared over 2a. Okay, maybe let's do one thing right away. You see, a is here, a squared is over here. So they cancel each other out. So let me just get rid of it right away. Okay, and finally, we've got plus c. Now, what I want to do here is to put all those numbers into common denominator. So in here it's really easy. I just need to multiply this expression, denominator and numerator by 2. And over here, I need to multiply c by in numerator and in denominator by 4a. So what am I getting? Well, the first expression is not changing. It's b squared over 4a. Then, okay, let me already put it in one fraction. So we will have negative minus 2b squared, right? 4a. And here, plus 4ac. Okay, and now look. I can calculate this out, and now I'm getting that this is negative b squared plus 4ac over 4a. Now, what should I do next? Maybe we can already know this. Have we seen this somewhere? This is almost formula for delta, but it has minus where it shouldn't and plus where it shouldn't. So I can take minus out of the whole expression. And now I have the formula for delta. And this is how we get that y coordinate of vertex is equal to negative delta over 4a. So now we've got all the necessary information that we need in order to draw any quadratic function. Okay, so now let's do 2 examples on how to actually do it. Okay, so now let's just say that the parabola that we have to draw is given by, let's of course do something very easy. 4x squared minus 4x plus 4. Okay, right away you might see that this can be done very, very easily in using other methods, but let's do it step by step using delta. So, delta, which is b squared minus 4ac, is, our b is negative 4, squared is 60. Then we've got 4 times 1 times 4, with minus up front, 16, it gives 0. So now, with delta equal to 0, it means we have just one repeated root, and the location of this repeated root will also give us the location of vertex. So, we get that x of vertex and x0 are given by negative b over 2a, which is simply 4 over 2, or simply 2. Now, what is y of vertex? Well, we don't need to calculate it here. But look, in the formula for the location of vertex on y-axis, we've got delta. Delta is 0, it must be 0. So now we are ready to draw it. Look. The coefficient on x is 1, it's positive, parabola will have heads up. Now, we know that x0 and vertex are at 2. Okay, to make it more realistic, I'm going to do it like this. And we're almost done. There is one more interesting point we would like to have. This one. How much is here? Well, it's really easy to calculate. At this point, x is equal to 0, 0, 0. We are just left with 4. Okay, let's just do another example. And in the second example, we will have y is equal x squared plus x minus 2. Now, how can we, so now let's approach this the same way. So we got delta is equal to b squared minus 4ac, which is 1. Then minus 4 times 1 times 2, negative 2, which gives us plus 8. This is equal to 9. So, knowing this, we can calculate x1 and x2, which are given by negative b plus minus square root of delta over 2a, which again gives us 4 plus, 1 with minus negative 1, right? Negative b plus minus square root of delta 3 over 2a, which is 2. Okay, so we've got first minus 1 plus 3, negative 1 plus 3 is 2, divided by 2, it's 1. Then we've got negative 1 minus 3, it's negative 4 divided by 2, it's negative 2. Okay, but look, right away, we can also calculate vertex. But, can we somehow, figure it out without it? Look, we know that vertex must be right in the middle between these 2 points. The space between them is 3, and the middle point would be negative 1 over 2. So, we can get that it should be negative 1 over 2. But let's check it. Of course, negative b over 2a, it gives us negative 1 over 2. Makes sense. And finally, we can calculate y of vertex, which is negative delta over 4a, and it gives us negative 9 divided by 4, or simply negative 2 this is and now we have enough information to draw the parabola. We of course again see that A is equal to 1, so the parabola will have hands up. Okay, so how do we draw it? I'm going to start with -2, 1, and here I'm going to put -1 over 2, and -2 and 1/4. All I gotta do now, is to connect all the points. Okay, the only thing missing we've got right now is what is the location of this point. If x is 0, y is -2. Okay, I think this is enough. And in the next video, we will consider some different, slightly more complicated functions. Thank you for your attention.